Okay, I'm going to work some problems out of section 1, chapter 5, just to demonstrate how these should be done. In the first problem, we're supposed to rewrite the quadratic function in standard form and find the vertex. To put it in standard form, first we have to complete the square. So first thing I need to do is remove the a off of the x squared and the x term. So my a is 2. And I'm having a little trouble with my pen. And my b is 12. So I'm going to take and I'm going to remove the a off the first two terms by factoring it out. And that will leave me with x squared plus 6x. I'm going to leave some space and then I'm going to have the plus 19. To make sure you get it out correctly, you need to compute b divided by a. b divided by a should end up being the coefficient of the x term. So in our case, this would be the original 12 divided by the original 2, which would give us 6. Once I'm done with that, the next thing I need to do is move on and find what I need to add inside the parentheses to force it to be a perfect binomial square. To find that, I take half of that number I just computed. So half of b over a, which would be half of 6, which is 3. The 3 is the number that's going to end up inside the binomial. But in order to find what I need to add, I take the half of that number and I square it. So now I'm going to take 1/2 of the b over a, and I'm going to square it. So I get 3 squared. Not a very good 3. Let's see if we can fix that a little bit. So I've got the 3 squared, which gives me 9. So I add the 9 into the parentheses. Since I've changed the problem to compensate, I subtract 9. So I have a plus 9 minus 9, which is adding 0. Now I'm going to factor the first 3 terms in the parentheses become the perfect binomial square. So that would be the first 3, the x squared plus 6x plus 9. When I factor those are going to become x plus 3, quantity squared. The number that's in the middle of that parentheses will be the number that was over here on the 1/2 of b over a. Now, the minus 9 never got taken care of, so I have to distribute the 2 on the outside over the minus 9, and then I still have my plus 19. That gives me 2 times the parentheses, x plus 3 quantity squared, minus 18 plus 19, or 2 times x plus 3 quantity squared plus 1. This means that my vertex is going to be at the opposite of the number inside the parentheses, so not 3, but -3, and it does what it looks like on the outside of the parentheses, so it's 1. In other words, it moved left 3 and up 1. Now let's draw a picture of what this particular parabola would look like. We know the vertex is at -3, 1, and we know that the y-intercept should be at 0, 19, because if we're looking at the equation, when x is 0, the y value would be 19. So the y-intercept, I'm having a little trouble getting it to write, hang on. Y-intercept should be 0, 19. Let's draw a picture and see what that does. Since our function is 2x squared plus 12x plus 19, then we know that somewhere up here at 19, it has to cross the y-axis. So somewhere up here, we have a y-intercept. I also know that the vertex is -3, 1, which would put it over here somewhere in quadrant 2, left 3 and up 1. That means now I can judge whether it opens up or down. The leading coefficient, which is a, was 2, which is definitely positive, and since it's positive, it has to open up. That means that it has to look something like this. Now, if you're trying to determine what the domain and the range is, the default domain for all polynomial functions is going to be all reals. So we can write that as all reals, or in interval notation, that's going to be from negative infinity out to infinity. Now the range is only going to be the y values that are used. Since the lowest y value that's used is the 1 on the vertex, and it goes up on both sides from there, then our range is going to be from a low of 1 up to positive infinity. Let's take a look at a different problem now. What if you have a function equal to negative x squared minus 6x minus 13? In this case, my a is negative 1 and my b is negative 6. I still have to remove the a off of the x squared term so I can complete the square. That means, though, that the parabola is going to be opening down because a is negative. To find what the coefficient of the x term should be, I'm going to find b divided by a, which is negative 6, divided by negative 1, which is a positive 6. So when I remove the negative 1 off of the x squared and the x term, I will be left with a plus 6x on the inside. The minus 13 stays outside. I'm trying to complete the square and force it to be a perfect binomial times itself. To find the number that I need to add and subtract on the inside of parentheses, I take half of my b over a, which is half of the 6 that I had before, which would be 3, and then I square it. It's just a fluke that we got the same number twice. That's not normal. And then I'm going to end up with 3 squared, which will give me 9. So I'm going to add 9 and subtract 9 inside the parentheses. So I add 9 and subtract 9. That 9 corresponds to the number I got when I took half of b over a and squared it. Now when I factor it, I should end up with the negative 1 still on the outside, and then inside the binomial square, I'm going to have x, and the other number I should have inside the binomial square should correspond to the number I got when I did half of b over a. And it will include the sign. If it were a minus 3, it would be minus 3, but since it's plus 3, it's plus 3. Now, the 9 that was a plus 9 became part of the x plus 3 quantity squared, but the minus 9 did not. So in order to take care of it, I have to take the minus 1, multiply by the minus 9, and bounce it out of the parentheses. That's the distributive property. The minus 13 is still just hanging out. This gives me, once I simplify it, a negative times x plus 3 quantity squared plus 9 minus 13, which would become negative x plus 3 quantity squared minus 4. My vertex is going to be at the opposite of the number in the parentheses, so minus 3, and the y value will be the number outside the parentheses at the end, minus 4. Since my a was negative 1, it opens down. The y-intercept is given by the c coordinate, which I didn't list originally, but I can go back and add that at the top. C was negative 13. So that means that my y-intercept is 0, negative 13. Now let's go ahead and graph it. I added some tick marks to the graph so that we could get a slightly better graph. My vertex is at negative 3, negative 4. So from the origin, I'm going to go left 3, down 4, and put a ball there. Now from there, I know the y-intercept is 0, negative 13, which is down here on the y-axis. Because these graphs are symmetric across the line that goes through the vertex, that means that there is a vertical line going through the vertex at x equal -3. Since the y-intercept is at -13, and that's 3 away from the line, there has to be a matching point also at y value -13, 3 on the other side of that line. So I can count over 1, 2, 3, and there has to be a matching point there. And again, notice that it does open down, which is what I expected since the a value was -1. Now that we know what the graph looks like, it's easier to find the domain. Our default domain for all polynomial functions is all reals. We can either write it out in words or we can use the symbol -infinity to infinity. The range is only the y values that get used on the graph. In this case, the vertex is at -3, -4, which means -4 is the biggest y value that's ever used, but it does use all the values below that. The big values go on the right, small values on the left. That means the range is from -infinity up to -4 and including -4, so we make it square instead of round. Let's look at another problem. In this problem, I'm given the graph of an equation and asked to find what the equation is. For this one, I can tell immediately that the a value must be negative because it is definitely opening down. So a is a negative number, whatever it happens to be. In order to find it, I'm going to use the standard form for the quadratic equation. So the standard form is going to be the following. The standard equation is a times the quantity x minus h quantity squared plus k. What can I take from the picture that will let me do this? I know the a value is negative. I can't see where it crosses the y-axis, so I can't find the intercept, but can I find the h and the k values for the vertex? Our vertex is going to be at hk. So the vertex is at hk, so I'm going to come over here to the graph and I'm going to find what that value is right there. The vertex appears to be at -4 for the x and -2 for the y. So I have -4, -2. Plugging that into my equation, so far I have a times x minus for the formula and -4 for the value of h squared plus a -2. Now instead of writing plus -2, I could write -2, or I could write a times x plus 4 quantity squared minus 2. Now I need to find another point where it cuts exactly through the corner of the grid in order to find the missing value, which is a. It looks to me like it goes through this corner right here at the ordered pair -3, -4. I'm going to plug the -3 in for x and -4 in for f of x, or for the y value. Remember that f of x can always be replaced with y. This will give me -4 equals a times -3, hang on a second, -3 plus 4 quantity squared minus 2. -3 plus 4 would be 1. 1 squared is just 1. So I get a minus 2 equals -4. When I add 2 to both sides, I get that a is a -2. This lets me write the equation of the line as f of x equals -2 parentheses x plus 4 quantity squared minus 2. That would be the equation of the line.